All right, so we have a differential equation on the board, and they are saying that we should find the solution of the differential equation. Here, what we are coming to today is that we will test several methods before we can get the solution. But we have the ones that you can check it straightforward just to know whether it will satisfy that method or not. So we have this question on the board. The first method we will check is what? The separable method. Now here, we need to check whether we can separate this. Now, just look at what we have on the board very well. You can see that there is no way we can separate the x variables from the y variables. So in this case, the separable method will not work. Then we'll go back again and check. Do we have another method? Yes, we have the exact method. The exact method is saying that if we have a differential equation which is in this form, then this equation must satisfy a condition, and that condition is. So if you don't know this condition, you can also search for the method of using the method of exact to solve a differential equation from this channel, and you get to know the meaning of this. So if you check this condition and this condition doesn't hold, then it means that we need to also check for another condition. So let's see whether this condition will hold for this question. If it doesn't hold, we have another method called the integrating factor. So here, let's see what we can do about this. So I have x squared minus y squared. Here will be the x plus here will be 2xy dy. So the reason why I am having this here, there is the x is this. We have y prime. We always know that our y prime here is equal to the y over the x. But the main idea behind this is that we want to write this differential equation in this form. So because I have this attached to this, so what I will do is that I multiply through by dx. So this is what I'm having right now. Now, right now, let's see whether the condition holds. So here, if you compare this one to this, my m here is equal to x squared minus y squared. And my end here will be also equal to what? 2xy. So I will differentiate this one with respect to what? Y. So I will differentiate this with respect to y, which is this. And I will get negative 2 what? 2y. I will also differentiate this one with respect to x. Then I will also get 2y. Now, if you check, you can see that they are not equal. What I have here is, per the condition, my, that is m sub y, should be equal to n sub x. So this one represents this one represents this. So that is the meaning. Now, if you check, you can see that they are not equal. So since they are not equal, we need to use another condition. And that condition is the integrating factor approach. With the integrating factor approach, we are saying that if you have an integrating factor, if you use it to multiply through the differential equation, it will make it exact. That is, this condition will hold. So before that, let's find the integrating factor. We are saying that if you have an integrating factor like this, then if you are having a differential equation where you'll be using the integrating factor to what to find the general solution of the differential equation, then what we will do is that we have the formula for the integrating factor, that is if integrating factor, which is equal to e raised power integral mu of, so let's do it like this, mu. What we have here is a function. So here I can say mu of x dx or mu of y dy. So I will use this or this depending on uh, what the question is requesting from you or what you will get from the question. So let's see, I just want to find this. This one too has a formula. So let's see the formula. Now I have mu of x, which is equal to, so here I will get my minus nx over nx. So here, this formula is saying that if you use this formula, you need to get a function which is in terms of x only. So if you get y attached to this by using this formula, it means that this one, we cannot use it to find the integrating factor. that means you need to use the other one. So that is why I'm having mu of y, which means I need to try the other one, which will give me a function in terms of y only. So in this case, I will also try this formula. Mu of y is equal to, so here it will be nx minus my all over m. So I have a way of chewing this formula. Yes, we have a way of proving it. But as for me, because I want it in a fast way, so what I will do is that I have to chew this formula. So here you can see that n is last, right? And here I'm having n at the denominator. So the one I'm having it at the last, the sub of it will give me, that formula will give me in terms of x only. Meaning that if this is last, x is last, then it means the function, if I use this formula, it will give me a function in terms of x only. Here you can see that y is last, and I'm having m and the m here. So which means that this equation 2 will give me a function in terms of y only. That is how I choose this. So assuming if you want to know all these two without getting yourself confused, this is how you do it. All right. Now let's see. So we are using the formula to check whether you will get this. So I have my. What is my my? My my is what? M sub y. M sub y is negative 2. So I'll get negative 2y minus nx, which is n sub x, which is 2y. So this over the n. Where is my n? According to this, my n is 2xy. So if I solve this one correctly, I will get negative 4y over 2xy. Now I can do cancellation. So if I do cancellation, this will cancel this, right? And 2 will also cancel this one. So right now, my mu of x will give me negative 2 over x. So we are saying that if you use this formula, it will give you a function in terms of x only. And you can see that I have it in terms of x only. That means there is no need for me to use the second formula because I can use this one to find the integrating factor. So since I have this, then it means I can find my integrating factor. So let's see how I can get my integrating factor. So I'm going to use this formula. So I have this one. I will substitute this one over here. So I will get what? I will get negative 2 over x here. That will give me my integrating factor. So in this case, let's see. So I'm integrating this with respect to x. That means I will get, so I'm bringing the constant out. If I do that, this one will give me ln. If we differentiate ln of x, you will get 1 over x. So if I reversing it, you will get ln. So here I'll get e raised power minus 2 ln x. Now the next thing I will do is that because there is ln here, I need to simplify. So I'll bring this one here. I will get e raised power ln x raised power minus 2. But you know that this one will give me x raised power minus 2. Right? So since I have this, now it means that my integrating factor will be equal to x raised power minus 2, which is the same as 1 over x squared. So I'm going to use this to multiply through the question again. And this will make the question what? Exact. So let's see how we can do it. So right now, I'm coming to use my integrating factor. This is my integrating factor. So right now, my integrating factor is 1 over x squared. So I will use it to multiply this. I will get 1 over x squared multiplying x squared minus y squared dx plus 1 over x squared multiplying 2xy dy, and it should be equal to 0. So here, if I simplify this, I'll get 1. This times this will give me 1 minus this times this will give me y squared over x squared all dx plus here this multiplying this, I'll get 2 over x, then there is y here, which is the same as 2y over x dy, and it's equal to 0. So the main thing, this is the main thing we are going to use. So let's forget about what we have over here. All right. So I want to check whether it will be exact. So here, if you check it again, my m here will be equal to 1 minus y squared over x squared. And my n here will be equal to 2y over x. So I have to differentiate this one with respect to y. That is m sub y. So if I do that, I will get negative 2y over x squared. Is that true? So this is constant. If you differentiate it with respect to y, it will be 0. Here it is constant. So I'm differentiating this, then I will leave this. So if you do that, this is what you will get. Now what I have over here is the same as 2y x raised power negative 1. It's true, right? All right. So I am differentiating this with respect to x. I'll bring this one down and subtract 1 from this. So if I do that, I'll get nx is equal to negative 2x 2y x raised power negative 2. So this and this are equal. Because this is negative, so it will come down and become positive. So if I write it correctly, then it means that this one will come down and it will become x squared. So if you compare, you can see that they are equal. So since they are exact, we will assume that there is a function f which has been differentiated with respect to x and with respect to what y. Do we get it? So here, when you get to this side, you use the exact method to solve the question. So let's see. I have f which has been differentiated with respect to x, and that one will be equal to what I have over here. So 1 minus y squared over x squared. And this will give me equation 1. Right? The second equation too, I'll get fy, which is equal to 2y over x, and this will give me equation 2. So right now we are coming to work with this. Now let's clean the whole thing. So I want the one which, if I integrate, it will make the thing easily for me. So what I will do is that here I will integrate with respect to y on both sides. So if I do that, I'll get f is equal to, I'm integrating with respect to y. So here it will give me y squared over x plus constant in terms of the other variable, which is this x. So this will give me equation 3. Now after getting this, what I will do is that if I differentiate this one with respect to x, it will be equal to this. So let's differentiate. I will get negative y squared over x squared plus c prime of x, and this will give me equation 4. So here you can see the equation 1 and 4 are equal. So therefore we equate them. Let's equate them. If I equate them, now you can see that this and this are equal, so I will cancel it. So I will cancel this and this, and therefore I will get c prime of x is equal to 1. Here I will get, if because I want what this, so I have to reverse the process. That means I have to integrate both sides with respect to x, and I will get c of x here is equal to, if you integrate this, you will get c plus s plus k. Then you will substitute this one over here. So let's do that and see. So if we do that, we will get y cubed over x plus, here will be x plus k. Now, there is a condition that if you have this, our f here will be equal to a certain constant k1, right? So you will substitute that one there, k1. And you know that k1 minus k will give us a certain constant c, which means a constant minus constant will give us a constant. So if we do that, you will get y cubed over x plus c plus x, and it should be equal to c, because this one will come here, and we will get k1 minus k. So k1 minus k will give us a constant, and I think that is the end of our solution. So this is the general solution for the whole thing. And please, if you want to get more of this, subscribe to our channel. Thank you for watching.